Be or not to be protected. Respirometry in ducks unlimited Canada. In 1937, a group of North American waterfowl hunters realized the wetlands were in trouble. The hunters dedicated themselves to protecting these ecosystems and their connection to nature. With no formal conservation background, they used citizen science and determination to make Ducks Unlimited Canada. DUC is an NGO that conserves, protects, and restores wetlands and habitats of the North American waterfowl and other native species, ensuring biodiversity conservation.
DUC's conservation regions include the Fraser Valley Delta, Pacific Interior and Coast, the Great Lakes, the Atlantic, the Prairie Potholes region, and the Canadian Boreal Forests. These areas have all been chosen due to the importance to waterfowl habitat, position in their migratory route, and the need for wetland ecosystem function and restoration.
DUC works with governments, other NGOs, and landowners to buy properties and wetland habitats, restore them, and in many cases, sell the property with conservation easements. These permanent easements prohibit new owners from using the land for anything other than low-impact purposes such as grazing or haying while pledging to conserve natural areas. These properties are then sold at a discount to make it attractive to buyers, and funds are reinvested into other struggling habitats in DUC's revolving land program.
25% of the world's wetlands are in Canada. Wetlands ensure Canada has clean water by natural filtration of pollutants, prevents floods by slowing down and storing water, sequesters carbon, and provides habitat for over 550 species of animals. A wetland's ability to provide these ecosystem functions is limited by its health.
A major challenge DUC faces is they lack the ability to quantitatively measure ecosystem health and restoration success. DUC treats waterfowl as an umbrella species, as their protection protects many other species as well. However, waterfowl are also known as indicator species. Measuring their health provides insight into the ecosystem's health.
Our aim is to help measure restoration success through changes in waterfowl metabolic rate, as well as validate the change in CO2 production of an organism as a metric for restoration success.
In the Great Lakes near St. Lawrence, eutrophication is a major issue for birds such as the mallard. The nutrient runoff into these lakes cause algae blooms and result in oxygen dead spots, killing plant and fish species and interrupting food webs. This lowers species populations such as the mallard due to starvation. As starvation lowers metabolic rates, measuring metabolism before and after restoration provides insight into its success, with an increase in metabolism being the goal. A decrease or no change in metabolism indicates a restoration failure.
We propose the use of non-dispersive infrared spectroscopy in wake respirometry to measure the metabolism through CO2. CO2 is more sensitive to fluctuations in respiration than oxygen, and this will allow for a more accurate metabolic indicator of stress responses. Using wake respirometry, we will be able to measure the metabolism of waterfowl, specifically mallards, using the amount of CO2 they expel in their wetland nesting areas. Areas mallards are known to be loyal in returning to if they have had successful nests. CO2 is measured by comparing measured absorbance to reference standards while simultaneously incorporating the effect of other abiotic variables.
Measurements will be taken before and after restoration to measure relative metabolic changes, an indicator of stress. 10 mallards will be observed during this time, allowing for control of individual variation, and will be compared to the measurements of 10 other mallards and nearby non-restored ecosystems to act as a negative control. This will require portable, non-dispersive infrared CO2 sensors, anemometers, to measure wind and speed direction, and infrared live cameras all synchronized to data loggers recording measurements simultaneously within the nesting sites. These waterfowl may be unpredictable in where they rest and which direction they face when resting. To compensate, multiple infrared sensors will be placed in areas downstream from the nesting sites to ensure maximum compatibility. Additionally, humidity and temperature can affect the metabolism of these birds. Like the effect of wind, tools such as thermistors and capacitive humidity sensors will be used to measure and record these effects synchronously and will be accounted for in the VCO2 by multiple variable integration.
The health of these ecosystems isn't just important for the thousands of organisms that live within them. They're also integral to the restoration of natural city infrastructure and restoring valuable ecosystem functions. Knowing what restoration strategies work best saves valuable time and money that can be used to protect more sensitive wetland ecosystems across Canada. While land-based wake respirometry is in its infancy, the potential benefits for the conservation of wetlands are quantitatively measurable. Together with respirometry, Ducks Unlimited Canada can save everything, from the mallard to us.